Welcome to episode 4 of Renewing the Conversation, a series of interviews where we talk to leading industry professionals and experts about renewable energy and heating with a focus on the home and what challenges face the industry and homeowners.
Today we welcome Bob Beattie, a company director with over 40 years experience in renewable energy and heat pumps. In this interview, we talk to Bob about the use of heat pumps in commercial buildings, apartment blocks and homes, and he explains some of the differences between air to water, air to air and ground source.
Before we get started, we want to say a huge thank you to today's sponsor, the MCS, which define, maintain and improve quality by certifying products and installers so homeowners can have confidence in the low carbon technology they invest in. To find out more, head over to www.mcscertified.com.
Don't forget to hit the subscribe button below and please show us your support by giving us a thumbs up. Enjoy the interview. Hi, good morning and thank you for joining us. Today we're going to be talking to Bob. Heat pumps have been in the press and been spoken about a lot in the media recently, and we thought a good place to start would be asking Bob, what is a heat pump?
Well, a heat pump is a product that is built specifically to extract heat on the heating side, to extract heat from the outside air, which most people don't believe it, but even down to minus 25, there is heat in the air.
Wow.
It extracts the heat out of the air using the refrigeration cycle, transfers it through the outdoor unit, through the refrigeration process and a compressor, and into the internal unit. I mean, in some cases, a monoblock heat pump, it's very small. The process is in that box, but the heat generated by the system, even down to standard, probably down to minus 10, is probably you can still get 3 to 1 out of the system, depending on if you're looking at 55 degree hot water. Reality is they're highly efficient. And I mean, let's face it, if you switch on a boiler is inefficient from the minute you switch it on. But heat pumps, right through their cycle, through their life cycle, will continue to produce that performance. That efficiency.
Yeah, can you just expand on that a little bit? So what is the most efficient heating that you can put in? Is heat source one of the most efficient? And can you just expand a little bit on when you said that boilers are inefficient, for those that don't know why a boiler would be inefficient or how it's inefficient?
What it's doing is burning gas. And in the process of burning gas, you're losing efficiency. I mean, at best, it's probably about, when you buy it off the shelf, it's probably about 98% efficient. I mean, it's a fact of life. It's burning waste product. That's why we, in theory, want to get rid of them, because they're not as efficient as other sources of heat.
So what is the most efficient? Well, you mentioned there like air source and air to air, air to water, ground source. What is the most efficient of those in that category?
Ground source, without a doubt, because I mean, on an air to air, air to water, you're relying on the variance of the air and and what the temperatures are day by day, and the moisture in the air to extract the heat out of that. Whereas ground source, it's well established fact that below the ground surface, 3 or 4 feet below ground, the ground is very stable. Same as fact if you were using water as your source of heat. Water below a certain level is constant. The temperature is constant, and that's the advantage. I mean, to be quite honest, an air to air might be more efficient higher up the scale. You can get something like 3.5, 4 to 1.
Wow.
3.9 kilowatt comes to mind in one job to 1 kilowatt of energy put in. At ground source, what you're benefiting from for the heating season is the constancy of the temperature of the ground. If you live next to a canal, for example, and we've got loads of them in the UK, you can actually take the heat out of the canal water.
Wow.
And transfer it into the building using the same refrigeration process.
So you get different. You obviously, you get heat pumps that are 7 kilowatts, heat pumps that are 11 kilowatts. What exactly does that mean? Because is it when it's labeled as that? Is it the kilowatts that it's generating in heat, or is it the kilowatts it's using as a machine? What does that mean?
The ratings are the kilowatt output of the machine based on standard ratings. every manufacturer has to produce in their literature the ratings at certain conditions, certain ambience, certain water temperatures, 7 to 35, 7 ambient, 35 water.
Yeah.
Basically, every manufacturer has to put out test figures, and they are nominal figures for their product under test conditions. So the output will be shown as 7 kilowatt. Now, if you had 7 degrees outside and 35 water, you'd be getting, say, 7 kilowatt. But if you were actually down at minus 10 and 55 water, you'd be getting a different performance level out of it.
So Bob, how do you use that data in terms of sizing a heat pump for a particular property?
Me in my cozy little world would be asked to say, look, we need a heat pump at 7 kilowatt, 55 degree water. And basically I would run it through my LG software and tell them what it will do at those conditions. But I mean, each manufacturer, when they get off the standard nominals, which is what you see in the literature, the nominal outputs, I mean, they once they get off that, their performance may vary down at the lower ambient.
When people talk about heat pumps in the UK, everybody typically thinks of an air-to-water system, but obviously there are a variety of different heat pumps that are available, from ground source to air-to-air. Can you just walk us through some of the different types of heat pumps that you can get?
Yeah, I mean, we used way back at the days of Canary Wharf, the Dockland Development Corporation. We actually, when their exhibition centre over in the Isle of Dogs, I think it was, me and my friend Nick Cox put in a water-to-water heat pump in there, taking heat out of the docks through a heat transfer medium and heated their exhibition centre and cooled it, I have to say. But I mean, that's, if you think how long Canary Wharf's been around, that was being done then. The thing that people seem to get stuck on is air to water, which is what we're talking about, air source heat pumps, I mean, for domestic. But in actual fact, you've got a huge range of air to air. You've got a huge range of air to water. You've got water to air. You've got water to water. And you've got ground source, which is more or less a combination of things like water, for example. Ground source is obviously the most efficient because it's relying on the ground, taking heat out of the ground. But it's also can be the most expensive to put in. Ground source has got at least 3 different styles. But reality is, as I keep saying, there isn't one solution to the domestic market. I mean, like ground source, you tend, and I will be shot down for it, but you tend to have to have enough land. There are 3 different types of them. In some cases, they used to put the ground source loops into the construction of the building. I don't know how much, if that is done. I mean, when you talk to Beanland, he's a master at that, so he will probably dispel a lot of what I've said. But at the same time, I mean, to be honest, it's. I mean, boreholes. The last time I dealt with boreholes for ground source, they were 10 grand a time for a 5 kilowatt borehole. To be honest, as things have gone on, you've got more drilling borehole companies. It's probably become cheaper. There are things called slinkies, which is just laying the tubes underground. And I mean, in reality, problems I've had with boreholes has been the thematic grout they put down the boreholes. If that's not done properly, you've just wasted, shall we say, 10 grand. The thing is, air to air is, I mean, I've just finished a project that went on for about 18 months in Putney, where we installed air to air in 69 apartments. Before it was finally finished, it had already saved them 20% on energy. The thing with that was that each apartment of the 69 had their own heat pump. So and air conditioning, because they had nothing. They didn't have gas boilers. They don't have anything. With a few niggles, as you do domestically, they are generally very happy with what they've got.
And that's air to air.
That's air to air. Yeah, that's an outdoor unit with a variety of fan coils. In the case of Putney, it's ducted fan coils.
For layman terms, I mean, I don't think I've ever seen an air to air. So for an air to air, for me, is it basically like heating AC? So you're taking almost a unit outside and you're sucking in the air, making it warm, and then you're blowing it
It's air
into
conditioning.
into a house. Yeah. Okay.
It's air
Warm air
conditioning.
conditioning.
It's what you've got in your offices. We installed air-to-air in the Ideal Home show houses in 1990, showing my age. And I stood in the show houses listening to the people walking past, and I never met anybody who said that's rubbish. Everybody was saying, wow, that's great. People gradually over the years, and I'm sure you guys are the same, actually feel you may have a need for a cooling. I
Yeah.
mean, my house hasn't got it, I have to say, because my house is well insulated. But the fact is, the best way to describe it is it's air conditioning with heating. Now, the heat output from an air heat pump is probably about 1 or 2 kilowatts more than you get from the cooling. So if you've got a cooling unit of 7 kilowatts, you're probably going to get 8 or 9 out of it on heating.
Obviously, model houses in the UK are generally, they've got radiator systems in place.
Yeah,
If you were to consider putting an air-to-air system into place, does that, as a retrofit project, would that involve you having to try and add ducting to the house? And does it work in the same way as an air source heat pump that runs air to water, in the sense that you've got one unit with a buffer store that basically heats the water in an air to water system? Could you have one unit with ducting running throughout the house, or do you have to have individual units out the rooms?
Basically, what we have, and I think generally all manufacturers in the UK market have got what we call a multi-system, where you have one outdoor unit feeding up to 5 fan calls. The indoor units are quite cheap. They're as sophisticated as anything you see in the market, but they're connected to an outdoor unit that runs all 5 at the same time. Shall we say lounge, dining room, and 3 bedrooms, just as an example.
Yeah.
All 5 will run on cooling or on heating. I mean, my ideal situation would be, shall we say, an air to water heat pump with solar PV, solar thermal, and a battery pack. But how many people can afford that? You know, I mean, we're talking the mass market here. So, I mean, basically, what I've been seeing is, because most people still, depending on the costs, can't afford to, or they think they can't afford to have a heat pump in. And air to air is, I mean, if you've got a brand new boiler or a 5-year-old boiler that's working perfectly well, there is an element of, you've got X amount of time before you want it to be failed first before you spend money on something else. I mean, my view is that a stopgap measure, I mean, because air to air has probably got about, well, like most heat pumps have probably got at least 15 years if they're maintained properly. For those who've got, you know, a decent boiler that's operating correctly and performing as well as it can be, put an air to air in. Let the boiler do the donkey work at the bottom end of the temperatures outside, and use air to air to do the rest.
And if you're in a period home, like a Victorian farmhouse or, you know, any kind of period home, how do you then install that ducting into, like retrofit that ducting? Is it really costly and complicated?
You don't put large runs of ductwork in. I mean, for example, in the master bedroom, in the ceiling void, you could have a ducted unit that supplies air and ducts air. It's basically a 90-degree bend on a unit stuck in the loft. And you could do that upstairs. If you've got a big loft like I have, you could probably feed all 4 bedrooms with a ducted unit if you wanted to.
When you talk about the disruption of air to water, so for example, that's what we've got. So we've got a heat pump, and that feeds into our home, and then that warms up the water, and it's the hot water that flows through the radiators. So that's what we're kind of referring to when we talk about air to water. So what are you seeing from homeowners? Is that one of their biggest concerns, is the disruption of retrofitting?
I mean, to be honest, it's the biggest thing. I mean, I'm sure you guys have seen it in the media. I mean, the amount of times heat pumps are expensive. That's the headline. In fact, a heat pump isn't huge in itself, isn't expensive. I mean, we proved it the other day. It's probably between 2.5 and 3 grand, for a monoblock unit, standalone outside. I mean, the problem is that there's a lot of invested interests out there who've got a vested interest in not letting the government run with heat pumps everywhere. Most radiators and boiler systems are far too oversized, and that's what
Right.
people are used to. I mean, I did an exercise back in March, April. One of the contacts from the heating side said, "Look, if you want to know if your radiators actually can cope with having a heat pump connected to them, turn the temperature down to 45, 50 degrees and see how it heats the property." Now, I did that. And in fact, being a masochist, I actually went in, I inflicted that on the wife. And we run our house at about 20 degrees. And in actual fact, it saved me an absolute fortune just doing that.
How important is insulating your property if you've got a heat pump system, or you're about to put a heat pump system in? How important is it to then also consider the other aspects of your property, like drafty windows and, you know, letting that air escape or letting cold air come into the property?
Yeah,
What do you advise people to consider?
To be honest, the secret is, and I keep cutting across you, and I apologise. The secret is to do that first. My windows at the front were put in 20 odd years ago, so they're not sealed. I mean, you can sit in the dining room and you can hear the wind whistling through. The new windows, you don't have that. So I mean, that's the advantage of the technology. I mean, plus of course the seals break over a period of time. So basically, I got a deal and we did 3 windows. A good engineer, and to be honest, there's a lot of them, very good heating engineers. We'll do that exercise, perhaps go through that with you.
You said that actual heat pumps themselves are like, you know, £2,000 or £3,000 for just a monoblock. Is the bulk, I mean, because we're looking at figures in the press, for example, and we know from our own personal experience of installation, you're kind of looking at like 14, 15, 16,000 pounds. So is the majority of that cost just in the installation and the other additional parts that need to go in? So for example, maybe adjusting a radiator, or, you know,
And the tank.
Yeah, and the tank, exactly. So is that where you kind of, that's where the other you know, costs start to really build up?
Yeah, I mean, to be honest, I mean, that figure I gave you for 3,500 is with the contractor's margin built into it, because obviously you don't give away the holy secrets, do you? What margins a contractor's making on a product. But I mean, to be honest, yes. I mean, I think most of the heating engineers will tell you that heat pump. I mean, we've had discussions going on till late into the night with some of these guys, and basically they'll tell you that heat pump itself is not the expensive thing; it's the installation. Realistically, the actual installation can be, like you said, an old listed building will bring its own problems.
Yeah.
You know, without damaging the property and so on. But I mean, you can't always retrofit underfloor heating, for example. A good heating engineer would do a heat loss calculation of the building and actually tell you, you know, look, it'd be worth your while doing this. You should do, you know, I mean, anything you can do to reduce the load on the building is common sense. It takes it off the finished product. One of the things I think we need to do when we're going through all this change and getting the government to do something other than talk is to actually perhaps get an ombudsman for them, because basically I come across quite a few projects where people don't know where to go when they've got a problem. I've been dragged in on jobs to help out. It doesn't do me anything, doesn't make me any money or anything like that, but I just object to people being sold rubbish systems. Not the unit necessarily, it's how it's installed. And I mean, that's why we've got MCS.
So how important is MCS both to the homeowner and to industry professionals?
MCS are putting in standards. There are standards there being put in, but Joe Public needs to have, or Josephine Public needs to have access to that, you know, a 24-hour hotline, like we've got in other ombudsmen. But this particularly, because the councils used to have the trading standard offices, but you know, one would suggest they don't have the expertise or the contacts to actually drag the contractor screaming and kicking back to a site. MCS is a start, I mean, I'm also F-gas is the other thing for the split heat pumps. You need to have F-gas qualification because these guys are skilled in the use of the installation of pipework and refrigeration.
When a homeowner is about to embark on a project, especially with like things like heat pumps, where they've maybe not had any experience with this kind of installation before, what should they be looking for, and what should they be asking the installers in the first meeting when they, to get a good impression as to whether this is somebody that they should be looking to hire for the project?
So the first instance, you would ask the guy to do a load have a look around your building and see what he recommends. Make sure that the guy they talk to has got MCS qualification, F-gas ideally as well. Yeah. Let him have a look at what his recommendations are before you start. We talked about this, about the insulation, the double glazing, and so on and so forth. Things that are a cost, but they'll actually reduce the heat pump size. If necessary, ask them to take you around to one of their properties so they're done. You should be asking the same things that you would do if you were buying a big 65-inch TV or a BMW. You want to know what the service is. At least you know where BMW are. You know where Currys are. It's a given. You need to have the warranty. Every single heat pump manufacturer gives warranty. Now, it gives it to the contractor who should pass the paperwork on to you for you to actually follow through.
I think it's really important that if the government is, really serious about pushing heat pump and the heat pump industry forward, the consumers have got to have that confidence, and they've got to have the confidence to know that there is, as you said, potentially an ombudsman there to support them and to protect them, that they can get home insurance to protect their assets. So I think it's really important that it just seems like at the moment the heat pump industry's got so much to offer, but there is so much additional kind of support and infrastructure that's really needed now, that needs to kind of be brought forward to help elevate the industry and also elevate the confidence from the consumers.
So one of the comments that I've seen quite regularly online is that people say, oh, you've got a heat pump, good luck when that thing breaks, because it's going to cost you an absolute fortune to get this thing repaired. I mean, is there any truth to that?
No, I mean, to be honest, as I said to you, it comes back to the warranty element of it. If the unit itself has failed, and I mean, the codes, our systems and others are the same, you've got a whole series of fault codes. It tells you what the fault code is. You tell that to the engineers who installed it. They should be able to get the part or question the manufacturer to get the part and come back to site. As I say, the compressor, if it's a compressor, very rarely, I have to say. Hence, it's important to have warranty.
We've got a question from Derek, who's one of the contributors on Renewable Heating Hub, and he's asked whether there have been any advancements in air source heat pumps to get them to be more efficient when temperatures start to drop below 5 degrees centigrade.
Yeah. Next question.
So before we wrap it up today, Bob, is there any other parting pearls of wisdom that you want to impart with the homeowners? Any kind of advice or any pointers or anything that people should be considering, or anything that you personally think is going to be coming up in the future in the heat pump industry that people need to be aware of now to consider?
To be honest, I'm working at the moment on a large property where technically money is no object, so I'm told, where it's actually, we're looking at doing air conditioning and heat pump plus solar, using one system to heat and cool the building, supply hot water at the same time, cooling. When I get more on that, I'll let you know. There are a lot of heat pump projects going on. It just needs the contractors as well as the developers and so on to have a wider knowledge of it and not just stick with what they're comfortable with. And there's a huge number of district heating projects going on at the moment around the UK. Some are in early stages, some are already operating, where basically they're in some cases using mine shaft water. When Uncle Boris was actually London mayor, he had a lot of district heating projects going on around London.
Oh, wow, that's really interesting.
I've never found out where that went, because there's always a way, change of mayor, change the plan, don't you?
Yeah.
But I mean, keep an eye out for district heating, using heat pumps, big heat pumps.
That is interesting.
interesting,
Okay,
yeah,
wow,
definitely.
fantastic. That's a great one. So thank you very much for your time, Bob. It's been fantastic having you on. We've really enjoyed your insights, your industry insights, and I think that there's been a lot of takeaways
Yeah,
there. I've certainly learnt an awful lot today.
Great insights.
And we thank you very much for your time, and wish
all
you
right.
a great week ahead.
If you need anything else, let me know. You know where I am. If somebody wants to ask me specifically a question,
Leave a comment below.
Yeah.
yeah, and I being ex-military as well, if they annoy me, I'll soon let them know.
Brilliant.